Integrated 3, problem 10-130. So it says a hiker decides to spend his days walking around the countryside. On the first day, he walks 25 miles, but on the following day, he finds he cannot keep up that pace. On average, he travels a 5% shorter distance each day. If he can walk forever, how far will he go? Well, at first, I was going to make a table. And then I realized that this has got to be exponential because there's like a percent, like it's not decreasing, it's not linear like decreasing by a certain amount. It's decreasing by a certain, I don't know, percent. So if you're going 5% less each day, then that means you're going 95% of what you did the previous day. For example, if you went 25 miles the first day and then you want to go 5% less than that, that would be 95% of 25. That would be 20, can't see that, 23.75 miles. And you would keep multiplying that times 0.95 for each subsequent day. And so if I did want to make a table, I could, and it would just get smaller and smaller. There'd be like the first day was 25, the second day was 23 point whatever that said. The third day was 22.56. Oh, well, anyway, it would just keep getting smaller, but those are they miles? Those miles would add up, but they would just become a smaller and smaller number. So if he went infinitely many days, then, like it says, assume he can walk forever, then at some point it's going to dwindle down to almost nothing. And so this is actually going to be a geometric series. And at first I thought I was going to have to get the equation for it, which I think this is the equation for it. And then I was going to sum up a certain amount of days. But then I realized it's not asking me to sum up, after how far has he gone after the 20th day or something. It's saying he can walk forever. So when I go to my math notes box, I see there's amount. I don't know what page it is on your book, but it's up ahead, and it's called Geometric Series. And if you read this very carefully, and you read all the way down to here, it says for an infinite geometric series with an initial value of a and a multiplier. The multiplier, I never call it by its real name. It's a common ratio. We use R for the multiplier. I keep saying multiplier because I think you guys know from your previous classes, you know what that means because of the exponential functions that you have studied. But R is just the multiplier or the common ratio. So ours was 95.95. So if the series is getting smaller and smaller and smaller, at some point it's going to get very close to 0, and we can actually sum it up. And so all you have to do is just basically use this little formula right here, and I'll show you how. So this is the formula for summing up an infinite series. So remember they said A was the first term was 25, and then it's just 1 minus R. So R in our case was 0.95, so that's really just 25 divided by 0.05, and it just comes out to be 500 miles. So that's in one of your math notes boxes.